Yeah. Thank you, Manfred. It does. So I just wanted to add a few slides about SSD because HGST is an hard disk drive company, but it's also the number one player on SAS SSD in the market. And we grew even further when we acquired a bunch of companies in the last 3 years. STEC, I'm coming from STEC, that we pioneered SSD and ZFS together with Nexenta back 5 years ago, probably, when Nexenta was still a very small startup. So let me show you a few slides about, sorry, wrong button. Okay, what we propose for ZFS implementation. So you are very much familiar with ZIL cache. You need low latency and L2ARC implementation. And back in the days, we developed a, sorry, I still need to learn it. So these slides probably everyone in this room knows it, and it's more appropriate to comment how it works. But basically, you have synchronous write coming to the ARC, then committing to the ZIL. At that point, you can commit to the host the execution of the write, and then the data can go back to the main pool. That can be SSD or can be HDD, whatever it is. So I will learn it, I promise. So for the ZIL cache, we developed a specific product that is called ZeusRAM. It's an SSD, but it's based on DRAM. So it's only an 8 terabyte DDR3 fully backup on flash. So we have supercapacitor inside so that we can transfer the data to flash in case of power interruption. And that's the lowest latency device available in the market, being based on DRAM. So we are writing to the DRAM, fully protected, with extreme low latency. Normally the latency is in the range of 20 microseconds. We commit to less than 40 microseconds no matter what. The only limitation of the ZeusRAM is the fact that it is available in 3.5 inch. So for the people who cannot use 3.5 inch, we are suggesting to use our new 12 gigabit SAS Ultrastar SSD, the high endurance version that doesn't deliver unlimited endurance like a DRAM-based SSD, but still an extremely high endurance, 9.1 petabyte random with quite good latency, below 60 microseconds latency average. You probably noticed that here I wrote average, here is committed less than 40 microseconds. The issue with SAS SSD is that you can find some spikes in the latency. We are pretty good in minimizing the spikes. Most of the all-flash appliance manufacturers are using our SSD because of this, because of being able to level the spikes. Still is not as good as a DRAM-based SSD. So that's for the ZIL. For the L2ARC, we have been talking a lot today, this morning, and in the presentation of Nexenta about L2ARC. L2ARC is for speeding up read. So what you need from an L2ARC is for sure high performance, primarily in read, random read. High endurance, because even though this is a read-intensive implementation, you need to fill the cache with data, so you need to constantly write data into the cache. And obviously, high reliability. And this is what we are good at HGST. So the product that we propose for L2ARC implementation, it's the Ultrastar SSD 12 gigabit in 3 different fashions: 2 device write per day, 10 device write per day, 25 device write per day. Probably this is overkill for an L2ARC, so we see the majority of the implementation are still using 10 device write per day. Are you familiar with device write per day on the Mini? Okay, good. Good, asking the question. So basically it's how many times you can write the entire capacity of the drive every day for the entire warranty period. So we say 10 device write per day. For an 800 gigabyte, it means you can write 8 terabyte of random data every day over 5 years. 2 device write per day is the same concept, and up to 25. 25 basically, it's the equivalent of single level cell based SSD. So for L2ARC, it's probably overkill. You don't want to have twice as much as the flash, because there is a lot of over provisioning that comes into play to achieve such an endurance. But most of the implementation that we see require a 10 device write per day, and there are brave people who are satisfied with an entry level 2 device write per day. That for read cache, it's can be quite sufficient, mainly if you consider that today we're already shipping 1.92 terabytes, so 2 device write per day over a 1.92 terabyte SSD. It's a lot of writing. What's new? That's something really new. We announced it around a few weeks ago, 2-3 weeks ago. The release of our first NVMe compatible PCI Express. Are you familiar with NVMe? What it is? So it's basically a standardization of the PCI Express protocol for a SSD implementation. So that means that today you can use our SSD NVMe compatible, and tomorrow you can replace it with an Intel NVMe or a Samsung or whoever will come into the market, and you don't require our proprietary drivers anymore. So it makes the product much more usable, easier to use, interchangeable, but it gives also some other advantage. It allows to release a PCI Express in a 2.5-inch form factor, and it becomes a not pluggable device. So with the similar to what you are familiar with SAS SSD or SAS drives in general. So it's much easier to deploy, it's scalable. You don't need to switch off the server if you need to do any maintenance, like you should do with a PCIe 2.0 implementation. Plug and play, or pluggable as well, or swappable as well. So a lot of advantage that makes this new protocol the next wave of SSD implementation. And the main advantage of NVMe protocol, beside the fact that it's a standard protocol, is the latency. The latency is around 1/3 of SAS latency, so that allows us to release product today with latency that stay below 20 microseconds. So having low latency equals to much higher IOPS as well. So here on the current generation product, we already achieved 750,000 random read IOPS, which is almost six times more than what we can achieve on our best SAS SSD. There are not that many options in the market today, but more are coming. We did quite a good job in optimizing the performance, and even though there are not that many suppliers, there are huge differences in terms of performance in what's available. The other advantage of NVMe, I didn't say before, is that you can run with a longer queue depth. You can go with queue depth of 128, even up. And we show in this benchmark that we achieved twice as much as the performance of one of the other suppliers. There are only 3 suppliers today, so there will be for sure other coming. Every SSD player is committed to deliver NVMe into the market, someone sooner than the others. And that's for your exercise of tomorrow. Today, NVMe is compatible with Linux, Windows, UEFI, FreeSBS, VMware, Solaris, Oracle has its own implementation of NVMe, but it's not yet compatible with the ZFS. Nexenta is working on it. I know there is something going on. I don't know, probably you're already ahead of the game with the implementation of NVMe. but we are more than willing to partner with whoever is interested into developing the driver for a ZFS implementation. Questions?
Is there any sort of a dual ported version?
Great question. Yes, there are talks about dual ported. Today, this feature is not available. And it's not available not only from us, but from.
I understand because it's PCI Express.
It's gonna be we are planning to have dual port NVMe in the second half of next year. So in our next generation product in Q3 2016, we plan to have a dual port device. Today, NVMe, PCIe in general, it's mostly used for accelerating database. So it's mostly used on server acceleration. So dual port is not a feature that has been highly demanded for such an implementation. But the point is right. NVMe deliver much higher performance. So it's a natural evolution of SAS deployment into storage appliances, and dual port is a feature that is needed.
Okay, and is there a PCI Express working group standardizing this interface? Because
the NVMe Express?
No, the dual port.
The dual port
interface.
Yeah.
Is that a PCI Express working group?
It's the NVMe working group, as far as I know.
Yeah. Okay.
Cool. Any other questions? No? Well, thank you very much. Oh, sorry. Do you want to speak?
What was the question?
Just one quick question. Do you have any data on reliability of these new devices? Because you're talking about number of device writes per day on the other, but how about those?
So it's just as good as the HDD in terms of MTBF, 2.5 million hours. The annualized failure rate is much lower, obviously. I think I recall it's 0. Something. We are far lower than the average of the market with the widest SAS implementation in the market. There are many SSD suppliers in the market, few enterprise SSD supplier into the market. We own 50% of this market, and we're not the cheapest. It's all about quality. You buy SSD because of performance, but you don't want to get failure on your critical data. So quality is, it's together with performance, the main driver for SSD adoption.
Cool, fantastic. Well, thank you very much. By sounds of it, it sounds like HGST have a lot of work at the hackathon tomorrow. So